So it says in the lab that the scale is 1 to 24,000. But what does that mean? So when you have a scale like this, what this is saying is that one unit on the map is equal to 24,000 units in the real world. And that's whatever unit you're using. Okay, so 1 inch is equal to 24,000 inches. 1 foot is equal to 24,000 feet. Okay, so they're asking for centimeters in this lab. So 1 centimeter would equal, that's right, 24,000 centimeters. So in number 6, they ask you to get the actual distances in the ground in centimeters and record that in data table 1. So you're going to convert this centimeters to kilometers, which makes a lot more sense because 24,000 centimeters is pretty unwieldy. So first we're going to get 24,000 centimeters to meters. So how many centimeters in a meter? That's right, 100. So what we're going to do is we're going to take that 24,000 and we're going to divide it by 100 to get meters. So already we're only at 240 meters. Now we're going to go ahead and we're going to convert that into kilometers. So there's 240 meters to kilometers. I'll give you a hint. There are 1,000 kilometers. I'm sorry, there are 1,000 meters per kilometer. I'm going to let you finish the problem from there. Next, we're going to go ahead and we're going to take a string to determine the length of the river. And what you want to do is you just, as you go, follow the length of the river, matching it up to the big turns. Like this. This is something we do in person as well. Okay, now I see I have the length of my river. And notice it's a lot longer, a good deal longer than the length of measured like just from point A to point B. So your string length should look a bit like my string length. Then you're going to measure that using the ruler provided by Science Interactive right here. Measure it in centimeters, and you're going to convert that into kilometers. Now you're going to determine the elevation distance in feet between the 2 points. So USGS maps are often marked in feet. We're kind of weird that way in geology as opposed to other sciences. And that makes it people aren't used to that. So um and it's just because we work in geology, we work with a lot of practical people, like, people who work in construction and farming and that kind of stuff. And because they use feet, we use feet as well. So let's get a little closer to our map. Ooh, and we're going to zoom in here. And we're going to see what those contour lines. So this is the contour line crossing the river over here. And we're going to follow along the river. They did not give me, they did not make this easy. Did they actually have an undergraduate calculate this? Aha. So I have one contour line over here, and I follow it all the way down over here. And I see I have another contour line on this side over here, right there. Now, I don't have the numbers for those exact contour lines, but what I do know from the lab is that the contour interval is 40 feet. So I can see from this end of the map here, over here, and this end of the map over here, there's about a 40-foot difference. Now we can kind of say, well, it's a little bit, this end over here is a little bit more than 40 feet. This one over here goes a little bit below the contour line. So we can estimate that it's a little bit more than 40 feet. Now they're going to ask you to convert that 40 feet into, or 40, we'll call it 45 feet, convert it into something that makes sense scientifically, because usually we use meters. So their conversion is 1 foot equals 0.3048 meters. So what you want to do is that you have your change of elevation and you multiply it by that 0.3048 meters. So you're going to take whatever you estimated, 42, 45, both reasonable estimates and difference in elevation, and you multiply that by 0.3048 as listed in the lab. Now you're going to find Oasis Creek, and you're going to do the same thing and find the elevation difference. And those are the big keys to this first exercise in the lab. Let's take a look at the next exercise. So I hope that goes over some of the points that might have confused you. Now we're going to identify fluvial landforms by using Google Earth Pro. So I'm going to shut down my Pro right now so we can see it from the beginning. You should have Google Earth Pro because you've already done the earthquake lab. So you probably have it already downloaded. If you haven't done the earthquake lab, you'll need to install it. You don't need to open it in order to do this lab. You just click on the fluvial landforms, click on the KMZ file, close, and now we have our Google Earth to work with. So you're going to change your options. You're going to use tools. You're going to use your tools option. You're going to open tools, options, make sure that it's set to meters or kilometers. Mine already is because I've run through these. Hit apply, and then you go to A. And we have this beautiful meandering river here. And so you're going to have to record the type of feature that you're looking at. I may have already said it. Fluvial, if you go to fluvial landforms, some of these are very common. So we look at floodplains. it might help for you they're looking for the landforms listed here. The lousy thing is they didn't give you a map view of these landforms. So what I would recommend is you just go ahead and plop floodplains into your favorite search engine. And you can see, aha, that wiggle wiggle looks a whole lot like, with like, it's low and it's broad, looks a lot like what we've got going on here with the wiggle wiggle meanders. And then we have this low flat plain surrounding the meanders. So we say, aha, that's a floodplain. This one is not too bad. This lab is everything works. The landforms are pretty straightforward. If you go over the introduction, we're only expecting you to put in the landforms that are listed. And rivers, I find for most students are pretty easy to identify. Like there's not a lot of judgment there. So I think you're going to have a good time with this lab. I don't think it's terribly hard, but do please reach out to me if you have questions, or if you would like, would basically would like any support. And thank you for being my student. And once again, don't be afraid to reach out. Don't be afraid to email me. And I'll see you in the next lab.